I have this thing and I want to convert it to this. What should I do?
Sir, so we're going from an aldehyde to a carboxylic acid.
Yeah.
So do we reduce it?
We oxidize it. So alcohol to carbonyl, basically aldehyde, and then to carboxylic. That's the oxidation process. And if I do it directly, then I will have to do reflux. And if I want to stop here, that is distillation. Okay. And then both of them are oxidation. So in both of them, I will need acidified KMNO4 or K2Cr2O7. You know, A levels or in most of the exams, they use K2Cr2O7 for some reason. KMNO4 will give us the same solution anyway. And then this has to be aqueous, of course. If you don't use that, then obviously you can use KMNO4. And whether you write acidified or you can write H positive, both of them convey the same idea. Okay, here's another question. What happened here?
Sir, बीच में halide बन गई है.
Halide बन गई. How do you make a ketone convert to a halide? मुश्किल से काम है. So, okay. So we have gotten an alkene. So definitely यहाँ पर elimination हुई होगी, because that's how you convert a saturated compound to an unsaturated compound, either cracking or elimination. लेकिन कार्बन्स उतने ही हैं, 3 हैं, तो इसका मतलब है cracking तो नहीं हुई. So what do you eliminate to get an alkene? You dehydrate the thing, right? You use concentrated sulfuric acid, heated, to do that. So you need concentrated sulfuric acid with heat, and obviously reflux because you don't want it to evaporate. And what does that? You need an alcohol to do it. So X is basically alcohol. So X is basically CH3, CHOH, CH3. So this carbonyl group has been reduced. How do you reduce it? Again, by adding it to sulfuric acid or HCl. Both of them are strong acids. They'll provide H positive, which will reduce this thing. If you don't want to do that, a better option would be using a reducing agent like NaBH4. So you can use NaBH4, and that NaBH4 will basically reduce this thing. And you can have it in aqueous form. If you don't want to use that, you can use lithium aluminum hydride. And that one has to be in ether, because if it is not in ether, then it is not going to work.
Sir, I can't see the screen.
Sorry, it stopped sharing screen for some reason. Okay, so this is what we were working on. So now you know what happened there. Let me give you another example. So let's suppose we had CH3CH. Okay, what happened here?
Aldehyde to alcohol.
So there are two reactions here. Number one, aldehyde to alcohol. And secondly, alkene to alkane. The double bond went away. So to get rid of the double bond, you have done hydrogenation. You have added hydrogen there. So we have three different cases of this thing happening. We can use reducing agents. वो हमारे पास ये दोनों हैं. Or we could use hydrogen with nickel catalyst and heat. If we do that, we get the same thing. It reduces the aldehydes, but also gets rid of the double bond. ठीक है.
Say that again.
So basically, we have reduced it. You're adding hydrogen to the double bond, and that's again reduction. And there are three ways of doing that. You can use sodium borohydride, which is aqueous. You can use lithium aluminium hydride, which is dissolved in ether. Or you can use hydrogen with nickel catalyst. Okay? So this is what we talked about yesterday. अब आज का देखते हैं. Today we are going to talk about oxidation. We already know of 4 oxidizing agents. कौन से हैं? One is KMNO4, acidified and aqueous. Then we have K2Cr2O7, aqueous and acidified. Then we have 2 more जिनकी formulas हमें याद करना जरूरी नहीं है. In fact, अभी के लिए तो हम वो formulas समझ भी नहीं सकते. In A2 we will understand why they do what they do. ठीक है, ये 4 हमारे पास ऑक्सीडाइजिंग एजेंट्स हैं. इनमें से these are strong and these are weak oxidizing agents. ठीक है. अच्छा. Now, what are the color changes? KMNO4, what are the color changes?
So it goes purple to colorless.
Very good, purple to colorless. What is the color change for potassium dichromate?
It goes green to orange or orange to green.
Orange to green. One way to remember that is that in paper 3, we know of chromium 3 ion giving us green precipitate. And right now this is chromium 6 ion. So chromium 3 green and chromium 6 orange. Achha. We have talked about tolerance agent and Fehling solution before as well, but just to give you an idea, tolerance agent has silver ions which convert to silver metal, and that gives us a silver precipitate. We also call it a silver mirror test. And Fehling solution has copper 2 ions, which means it's going to be blue. But then it converts to red because it gets copper 1 ion. So copper 2 to copper 1. So that is another oxidizing agent. So हमारे पास ये 4 oxidizing agents हैं. Now the thing is, these oxidizing agents, only 2 of them are strong enough to do oxidation all the time. But 2 of them are mild oxidizing agents, weak oxidizing agents. ठीक है? तो इसका मतलब हुआ कि जो tolerance agent और Fehling solution है, they will react with aldehydes. They will react with aldehydes, but they will not react with ketones. Okay? Which means we can use them to test between aldehyde and ketone. मैं आपको 2 चीजें दे देता हूँ. आप कहते हैं दोनों carbonyl है. How would you differentiate? You know that aldehydes can be oxidized to carboxylic acid, but ketone नहीं हो सकता है. Which means you take one of these, and if they oxidize, that shows that they are oxidizing agents and that thing is aldehyde. अब यहाँ पे एक सवाल आता है, why use weak oxidizing agents at all? अगर आपको चेक करना है कि कोई चीज ऑक्सीडाइज होती है या नहीं होती, why not just use KMNO4, a strong oxidizing agent, all the time? Why do you think that would be? क्यों हम एल्डिहाइड को चेक करने के लिए या कीटोन को चेक करने के लिए इन दोनों को यूज करते हैं? Why don't we use the strong oxidizing agents?
Sir, because the strong one will oxidize it to a carboxylic acid.
Oxidize what to a carboxylic acid? Aldehyde.
Yeah.
And that's what weak one will do as well. Mild oxidizing agent भी तो यही करेगा. It will oxidize it to carboxylic acid. The reason we use these and not strong oxidizing agents is क्योंकि हमें एक रैंडम चीज को चेक करना है, एक टेस्ट ट्यूब है जिसमें हमें नहीं पता क्या है. Aldehyde होगा so it will oxidize and tolerance agent or filling solution will give me the colors. ठीक है, मतलब अगर मेरे पास tolerance agent होता तो I will get something like this. I will add it to a colorless thing and I will get this precipitate in there. ठीक है, this is a silver mirror test and this is what I get with tolerance reagent. ठीक है, and if I use that thing filling solution, it will give me a red precipitate. Both of them will do it, but the difference is that if I had an alcohol, then if I added KMNO4, it will oxidize that as well. अगर KMNO4 ऐड करूंगा तो अल्कोहल को भी ऑक्सीडाइज करेगा, एल्डिहाइड को भी ऑक्सीडाइज करेगा, बट फेलिंग सॉल्यूशन सिर्फ एल्डिहाइड को ऑक्सीडाइज करेगा. Would you excuse me a minute? So do you understand the reason we use a strong oxidizing agent is when we want to just oxidize stuff. But if we want to know whether we have an aldehyde and not alcohol, then we can use a mild oxidizing agent because mild oxidizing agents have no effect on alcohols. They can't oxidize them, but they can still oxidize aldehydes. इसका मतलब होगा कि मुझे फेलिंग reagent tolerance solution से ना सिर्फ कीटोन और अल्कोहल में फर्क पता लग रहा है, सॉरी कीटोन और एल्डिहाइड में फर्क पता लग रहा है, मुझे एल्डिहाइड एंड अल्कोहल का फर्क भी सामने आ रहा है. But does that mean that if I give you a random thing, then you wouldn't be able to tell whether it's alcohol or ketone?
Yes, sir.
Yeah, because
Sir,
it wouldn't tell.
Can we use a strong oxidizing agent?
I'm sorry?
Sir, but if we want to like distinguish between alcohol and ketone, then can we use a strong oxidizing agent?
Very good, very good. So here's the thing. If we have a random thing like A, B, C, we have three things. Now, I can use a KMNO4 solution, acidified, or Fehling solution. Okay, now here's the thing. With Fehling solution, A oxidizes, and it also oxidizes with KMNO4. B oxidizes with KMNO4, but not Fehling solution, and this oxidizes with none of them. What is A, what is B, and what is C?
C is a ketone.
C could be a ketone. We don't know for sure because we need positive tests. इसने अभी हमें कीटोन होने का कोई पक्का सबूत नहीं दिया. Like we can infer that it might be a ketone, but we are not sure. It could very well be a carboxylic acid because carboxylic acids also don't oxidize any further. So we don't know for sure whether it's ketone or carboxylic. But A and B have pretty much given us a lot of ideas. Like what is A? What is A?
Alcohol.
A is aldehyde.
Sir, but you said that strong oxidizing agent से नहीं होती.
If something can be oxidized by a weak oxidizing agent, then why wouldn't a strong one perform the same thing? So this is telling you that this is aldehyde. Yeah, so A is aldehyde, this is alcohol, and this could be a ketone, this could be carboxylic. We don't know for sure at the moment. Okay? All right. Now we are moving on to another test.
Sir,
that we do
how
for
is
test. Yeah.
Alcohol? How is
I'm
B
sorry?
an alcohol? Shouldn't
So
B
A is B is oxidizing only with a strong oxidizing agent, not with a weak oxidizing agent. So it could be an alcohol or it could be an alkene for all we know. अभी तक जो हमने पढ़ा उसके मुताबिक it could be one of these. If it was alkene, what will you get? You will get a diol.
Oh.
Okay, so if it was aldehyde, if it was alkene, you will get a diol. And again, that depends on whether it's cold or hot. If it was cold, you'll get diol. If it was hot, you will get carbon dioxide or ketone or aldehyde, depending on what happens there. Okay. So that's what we studied in alkenes. Usko bhulna nahi hai. KMNO4 is very versatile. But so far, Fehling solution has been unsuccessful, which means between aldehyde, alcohol, and ketone, these are the results that support our hypothesis. Clear so far?
Yes.
Great. Now I'm going to introduce you to this new compound. This is nitro group, and this has two nitro groups. So उसकी वजह से इसको dinitro बोलते हैं. And this ring, this hexagon with a ring in it, इसको हम phenyl बोलते हैं. So this is 2-dinitrophenyl. And NO2 are on the second and the fourth carbon. So why? Because on the first carbon, this one, you have another thing which is called hydrazine. Hydrazine is used to inflate airbags in cars. So hydrazine में हमारे पास ये होता है. Basically hydrazine ये होती है. N2H4. But अगर मैं एक हाइड्रोजन निकाल दूं और उसकी जगह पर ये डाल दूं डाइनाइट्रोफिनाइल, तो ये मेरे पास ये चीज बन गया, ये कंपाउंड बन गया. ठीक है. So we take hydrazine and we replace one hydrogen with this whole thing. So this is 2,4-dinitrophenyl hydrazine. Why is it dinitro? बताओ.
Because it has 2 NO2.
Exactly. And phenyl, because this ring, if it is a branch, then we call it phenyl. If it's not a branch, we call it a benzene. But if it is a branch, then we call it phenyl. ठीक है? ये नाम है इसका. And hydrazine. So अब इतना लंबा नाम है, तो हम इसको छोटा कर लेते हैं. हम इसको 2,4-DNPH बोलते हैं. Okay? So 2,4-DNPH. Now 2,4-DNPH is going to give us precipitates. ठीक है? और इसका अपना solution का color ये है, yellow. But when you add, so this is the color of the solution, the yellow one, but when it reacts, it can give us orange precipitate. अब सवाल ये पैदा होता है कि ये react कब करता है?
Sir,
So
what
this
does it react with?
यही तो question है. What does it react with? So turns out, do you notice these two hydrogens? These hydrogens, if you can take them out and make water from them, so that is called a condensation reaction. So whenever 2,4-DNPH does a condensation reaction, तो ये हमें precipitate देता है. If I already have two hydrogens, so what else do I need to बनाने के लिए मुझे और
Oh,
and the carbonyl का हो, whether it's aldehyde, whether it's ketone, हमें ये carbonyl का O सकता है, and that is what comes, and that's when you get a press. By the it is because of, but this gives us many colorful dyes and compounds जिनके colorful बहुत ज़्यादा bright
Can
colors
you
होते हैं.
repeat this? My internet cut off.
sir, your voice is breaking a lot.
Yeah.
I'm so sorry. I'll use my hotspot. Just give me a minute. Okay, is it better now?
Yes, sir.
Should be. All right, so I'll go again. Basically, this hydrazine particle, this has these two hydrogen in it. And these hydrogens you can take out in a condensation reaction and react them with oxygen of the carbonyl, making water. And whatever is left, you can join them. So ये carbon को हम इस nitrogen से join कर देंगे. And this nitrogen bridge in there, and nitrogen bridge बोलते हैं इसको, this is capable of giving us many brightly colored compounds. And that's what we get. And that's the precipitate that we get. So इसका reaction करवाते हैं. Let's look at an example. I have 2,4-DNPH. So I draw the hexagon, nitro here, N with another N with two hydrogens. Okay. Another hydrogen here. So this is 2,4-DNPH. I reacted with the, let's say, this compound. What is this compound? इसका नाम क्या है? This is ethanol. It has the carbonyl part and it has H as well. So this is ethanol. But that doesn't matter because these two hydrogen and this oxygen, they can join together and make water. So ये दोनों hydrogen यहाँ से निकल आएंगे और ये oxygen यहाँ से निकल आएगा and they will make water. Clear? The remaining part, we will just join them together with the nitrogen. And that thing is going to be very brightly colored. उसका orange color हो सकता है, yellow color हो सकता है, red का कोई shade हो सकता है. So this is going to be a very brightly colored compound. हम इसको orange assume करेंगे. Okay? So 2,4-DNPH किस काम के लिए use हो सकता है? आपने देख लिया कि condensation reaction होता है तो ये ऐसे करता है. So where can we use this? Wherever we have a carbonyl. अगर मुझे कंफर्म करना है कि मेरे पास कार्बोनाइल ग्रुप है, ये ग्रुप है, मुझे इसको कंफर्म करना है, तो I can just react it with 2,4-DNPH. And with 2,4-D and pH, only these things will react, the ones that have carbonyl group in them. Will alcohol be able to react with it? No, because alcohol doesn't have oxygen जो इस तरह से अलग जा सके. हाँ, it has OH, but यहाँ पे OH वाला reaction तो हो ही नहीं रहा है. It's not giving one hydrogen, it's giving both the hydrogen. Which is why we can use condensation reaction of 2,4-D and pH to confirm the presence of carbonyl group. Clear?
Yes, sir.
Great. So now we know how to differentiate between ketone and aldehyde, between aldehyde and alcohol, and also between any carbonyl and alcohol. The last reaction that we're going to do for today, because we actually have one more reaction left iske baad, but I don't want to do that today because I feel wo bahut zyada ho jayega. So iodoform is this compound CHI3. Do you know chloroform? Chloroform is CHCl3. So iodoform is similar to that. It just has iodine in there. Now, iodoform ka reaction bada zabardast hai. Iodoform is insoluble and it's giving us a yellow precipitate. So hum isko use kahan pe karte hain? It's very interesting. Every time you have carbonyl with a methyl, it's a very specific test. Every time you have a carbonyl with the methyl, this reaction works. जिसका मतलब है, it can work for ethanol, it can work for propan 2-one or any other compound like that. अगर यहाँ पे CH2, CH3 होता तो भी ये काम करता. Basically, as long as you have this thing, I'm sorry, could you repeat that?
Like these things, they react with iodoform and give the.
They react to make iodoform.
Okay.
Which is a yellow precipitate. Now, what do? We add iodine and sodium hydroxide. Okay. Now, what will we get? Examiner will usually not ask you कि बनेगा क्या. So this is just for your information. Basically, सबसे पहले these hydrogens are replaced with iodine, and then OH minus आता है. इसका पूरा एक mechanism है. I don't think we need to go into that detail. अभी हम छोड़ देते हैं उसको. We'll just look at what happens at the end. At the end, you're going to get. Sorry, that's Coco. She also wants to study chemistry. This is what we get. That's an ester. But esters are soluble. And we get iodoform. So do you get it?
Always get an F.
So basically, what's happening here is that as long as you have carbonyl with a methyl group next to it, you can add iodine in sodium hydroxide solution, which means you need to add alkaline iodine. I'm so sorry. आज गलती से मैं घर पे क्लास ले रहा हूँ.
No problem, sir.
So we add alkaline iodine. Basically, sodium hydroxide में iodine को dissolve करते हैं, and we add that to this thing. And it's a very specific test because it's telling us कि methyl next to carbonyl है कि नहीं. If we had this one, then it wouldn't react. ये नहीं करेगा. क्यों? Because carbonyl के साथ CH3 नहीं है.
Your voice is really low. Can you repeat this?
I will repeat it all. I think बहुत ज़्यादा distraction हो गई. Wait. Okay, so let me repeat. If you have carbonyl joined with a methyl, the conformation for this can be through iodoform reaction. What is iodoform reaction? Obviously, यहाँ पे कुछ भी हो सकता है. But as long as you have a carbonyl next to a methyl, if you add iodine with sodium hydroxide or any other potassium hydroxide we use हो सकता है, it will create an ester. The sodium and the oxygen will go in there. और हमारे पास ये चीज बनेगी with iodoform. इसको बैलेंस कर लेंगे हम. And this thing,
ester हमेशा बनेगा.
Ester बनेगा, definitely ester बनेगा. And this is the solid which is yellow in color. Now, if you want to know into detail ना कि ये होता क्यों है, क्यों हो क्या रहा है यहाँ पे. So let me break it down into multiple stages. सबसे पहले यहाँ पर हाइड्रोजन को सब्स्टिट्यूट करेगी आयोडीन. ठीक है. And by doing so, you get this. और अब यहाँ पर हाइड्रोक्साइड आयन आएगा और हाइड्रोक्साइड आयन बेसिकली क्या करेगा कि इस पूरे की जगह पर आ जाएगा. So यहाँ पर you will get this and the other thing will get the hydrogen. ये हाइड्रोजन इनको मिल गया and you get CHI3. लेकिन अब ये ऑक्सीजन अकेला क्या करे? So this whole thing, the ester part, reacts with any available positive ion, which is sodium in this case, and it forms sodium, whatever ester you have. So it's a 3-step process, but examiner will not ask you about this process. Examiner आपसे क्या पूछेगा? आपको equation भी नहीं पूछेगा. Examiner आपसे कहेगा ये compound है, बताओ इसमें yellow precipitate बनेगा कि नहीं बनेगा. Now you know yellow precipitate तब बनता है when you have CH3 next to carbonyl. And I guess that's it for today. I will go over the last reaction for carbonyls tomorrow. That is addition. काफी important reaction है. So we'll do that tomorrow. And again, sorry about today. This was so haphazard.
Oh, sir, we like cocoa.
Yeah. Okay.
Okay, sir.
Hafiz.
Hafiz.